Okay. Well, I'm hoping to make this section as enjoyable as possible. It's like when the doctor has to give you a shot, right? How nicely can they give you the shot, you know? That's kind of what I feel like, because I have bad memories of this section. But I think it's going to make some things easy. I hope so. So the first thing we're going to do, we're going to look at a couple of identities. And the best way I like doing these is just using the calculator and seeing what's happening, okay? So the first thing I want you to do, just make sure you have your calculator in degree mode. And I want you to type in sine of 30 degrees and sine of negative 30 degrees and see what you get. And we'll do sine of, 100 degrees and sine of negative 100 degrees. Let's see what you get. Just put that, just enough decimals to get the idea. And then do the same thing for cosine. Do cosine of 30, cosine of negative 30, cosine of 100, cosine of negative 100. Make sure you're in degree mode. All right, who has cosine or sine 30? What'd you get? 25. Sine negative 30.
Negative.
Correct. Sine 100. Just 2 or 3 decimals is fine. 0.98. All right, that's good enough. What'd you get sine of negative 100? Negative 0.98. So what are you seeing that happens if you do an angle and the negative angle? What do you get? The negative of that angle. What happens? Like what I'm asking is if we do sine of theta and we do sine of negative theta, are those equivalent? No. They're off by what? Yeah, so in order for these to be equivalent, what do I need to add to this equation? What are these answers of each other? That's right. It has to be another negative. They're opposites, right? So I'm just going to put a negative here, okay? They're opposites of each other. They're not equivalent. They're opposites. Now, you may see with x, so they may write it sine of negative x equals negative sine of x. You may see it written like that, okay? All right, what happens here? What'd you get for cosine of 30? 0.866. Cosine of negative 30? 0.866. Cosine of 100? Negative 0.1. What'd you get cosine of negative 100? So what happened with this? If I do an angle, I do the opposite of the angle, what happened to your answer? Stay the same. So cosine of negative x equals cosine x. All right? And these are actually called the even and odd identities. Remember way back at the very start, we talked about even and odd functions. And an odd function is when you do the negative x and you get the opposite. And the even function is when you negate x and you get the same answer. Now, rather than keeping to go through all six, I'm just going to give you the other ones. Now we could derive them. So let's say tangent of negative x. I want to derive that, right? Here's how I can do it. I'm going to derive tangent. I'm going to see what it equals to with just x. And here's how I'm going to derive this one. I know tangent of negative x. Is there any identities with tangent that you can write it with sines and cosine? Sine over cosine. Again, if I don't know my identities, I need to have the first thing when you hear identity, I go to identity sheet. He said tangent, sine, and cosine. Boom, boom, I'm looking. Tangent is sine over cosine. So I'm showing you how I'm going to use those identities to derive this identity. What does tangent of negative x equal? Well, we're going to prove it. We're going to prove what it equals. All right. So first of all, is everybody good with this from our identity sheet? Whatever that angle is, it goes here. Now, these two, we just got the identities. So what does sine of negative x equal? Very good, negative sine x. What does cosine x equal? Cosine x, okay? All right. See, now I've gotten rid of the negative x on the inside. I just have x's now. And now I'm going to go full circle. With the negative, what is this? Tangent. Sine over cosine is tangent x. So now we've proved that tangent of negative x is negative tangent x. It's an odd function. Okay. All right. I'm not going to do the other ones because they're just the reciprocals. If I flip, do I lose my negative? If I just flip something, do I lose the negative? No. So if there's a negative, it's going to stay negative. So cosecant is the flip of sine. It's still negative. Oops, I don't want to put negatives. If I have secant, which is the flip of cosine, it's going to go positive. Okay, because if cosine and secant are reciprocals, you flip a positive, it's still. And then cotangent is the flip of tangent. So cotangent of negative x is negative cotangent x. So you're going to see that cosine is an even function later on, and secant is an even function. What do you remember about even functions in terms of their symmetry? They have y-axis symmetry. You're going to see that they have symmetry about the y-axis. All right. So if those two are even, guess what all the other ones are? They're odd. So odd function, odd function, odd, odd, odd. What do odd functions have symmetry about? The origin. They're symmetric about the origin. It's like two flips. So odd means you're symmetric about the origin. So we'll see that later on. When we get, remember I showed you the waves the other day. That sine and cosine are waves. Okay? All right. Okay, so there are our 6 even and odd identities. So it was difficult for me to grasp the, so what the problem is, the book is the book, and the homework it has is the homework. And they give the problems out with that dreaded wagon wheel, but that dreaded wagon wheel is filled out. Like when I was a kid, they gave me, when I was in high school and I was doing trigonometry, because we actually had that class, trig, it was called trig. You got this picture. Just ring a bell? Have they given you this here? I think Cron does it. Right? And then you're told that this is the point 1, 0. And then you're given some points. So like you're told here that this is the point, the square root of 3 over 2, 1/2, something like that. And then this one is, they rationalize, square root of 2 over 2, square root of 2 over 2. This is 1/2 square root of 2. And they're all filled out. And this is the point 0, 1. And then all these are filled out. Have you seen this picture before or no? They're going to give you this picture. What I typically do is I like to teach you how to fill it out yourself. So that way you don't have to rely on that picture. Where any of these we can determine what they are. Okay, like if we want to know what this point is here, this would be a 30-degree angle. This is 45. Of course, that's 60. And then all your reference angles over here, from what we did the other day. So, and then all this is filled out, like there'd be, you're gonna see it's here, 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 it's got all of them, every point. So like here, I believe is, what's that, that's 210. So at 210, let me not mess this up, should be negative square root of 3 over 2, negative 1/2. Right, and then so on. So it's awful to look at. Here's all I ask you to do. So first of all, if we're talking about the unit circle, so unit circle just means, so I'm going to erase this, but does this ring a bell, this picture? Don't worry about filling it all in, because we will. We'll show you how to do that. First of all, let's just talk about a couple of things. What's the unit circle? The unit circle, anytime you see the word in math, unit means like ways to measure something, but unit also means one. It means something of length 1. Unit circle, something's 1. Unit vector of length 1. Okay? So unit in math doesn't always mean that, like meters, feet, pounds. It means 1. So unit circle means the radius is 1. And a circle centered at the origin is always x squared plus y squared. If the radius is 1, so r squared, that's the equation of a circle, x squared plus y squared is 1. That's the equation of the unit circle. Okay? So it's centered at the origin. So all I ask students to memorize is this. If we draw a circle centered at the origin with radius 1, that means from the center to the edge is always 1 unit. So there should be 4 easy points to know. That's all I ask you to memorize. So what point is this? 1, 0. What point is this? 0, 1. What point is this? Yep. And what point is this? 1. So that's all, in terms of the unit circle, that's what I want you to memorize. Don't worry about all the spokes of the wagon wheel, because that thing can be crazy. Now, the question is, why is this so important? What's the application of it? I can tell you this, I use this thing on a frequent basis in calculus class, because it helps me evaluate. See, it's used to, it's all this, what we're trying to do is make evaluations. How can I evaluate these tree guys fairly quickly, okay? Without always having to go to my calculator. The problem that where you ran into over here, even though we don't have a way to do it in the other way, that's not an exact answer. Luckily, this is exact. This is not exact. So if you typed in sine of 150 on your calculator, you would get a, no, that one is 150. We don't want that. We want 120. You would get that, but that's not exact, right? We want to be able to make the exact computation. So, okay, so there's the unit circle. That's what it looks like. What does this have to do with trig? Well, I'm going to show you. So here's what we're going to do. We're going to find this first. So if I draw an angle here, so the idea is any angle you draw will always hit a point on the unit circle. Okay? I mean, it's going to cross at some point. So every point on the unit circle can be hit by an angle. An angle can touch that. But then something interesting occurs, and I want you to see that. So forget about this for a second. Do you remember what sine of 30 degrees is and cosine of 30 degrees? If you need to draw the triangle on your paper, draw it real quick. Do sine of 30, cosine 30, write your answer down. Don't use your calculator. Don't use your calculator. Come on. Sine of 30, cosine 30. If you want to draw it into the first quadrant, I don't care. Just draw your triangle 30, 60, 90, get sine 30, cosine 30. And I'm going to put you under pressure 20, 19, 18, 17, 16. It needs to be done this fast. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, hopefully you have the answers. So let's see. Sine of 30 degrees, Michael. I said 0.5. 1/2. Cosine of 30 degrees. 33 over 2. 33 over 2. So you need to, what do you have to have? The 30, 60, 90 triangle memorized, all right? So you have your 30, 60, 90 memorized. All right, you could draw it on the axis system if you want, 1 squared is 3, 2, and then you do your SOHCAHTOA. All right, did I do that in about 20 seconds? Yeah. Okay. All right, just what we're testing you, we're just seeing you how quick you can do it, okay? Now here's what I want to show you. So now we're going to draw that 30-degree angle here, and we're going to see what point it hits here and how this point relates to those answers, okay? So all I'm going to do is remember the recipe, the long recipe I wrote on the board, right? So we're gonna do 30 degrees, and essentially what we're looking for is this leg and this leg, right? Because if I remember how I always said, here are the legs, and these legs go to that, represent that point. We're gonna find this leg and this leg. Okay. All right, so what are my steps? So I have my 30 degrees. Step 1, draw the angle. I did that. Step 2, draw up a perpendicular. There's that. Okay, good. What's step 3? If you don't know, get your recipe out. I asked you identities you don't know, have your identity sheet. Find the reference angle. What's the reference angle? 30, there, boom, okay. Why do we need the reference angle? Or we can find the sides, okay? So what are the sides of a 30, 60, 90 triangle if this is 30 degrees? What's this? 1, very good. What's this? Very good. What's this? 2, all right, and stop. I just contradicted myself. Okay? What's the contradiction, Andrew?
Well, that line, the bottom one that says it's square root of 3 should actually just be 1.
No. That's not the contradiction. It is a contradiction. This is 1. This is to here. See? Well, what's square root of 3 anyways? Yeah, but be more specific. 1 point something is bigger than 1. So what's the contradiction? If I'm saying this is square root of 3 and to here is 1, what's the contradiction? That's over 1. We got a problem. Look, this is the what of the circle? For a circle, what's that?
Radius.
What's the radius of the unit circle?
1.
Something's wrong. But listen, on a 30, 60, 90 triangle, when we look at it, yeah, this is the reduced, the sides in there, like the most reduced form. If I wanted, I could multiply every side by 4, and I still have a 30, 60, 90. It's just similar triangles. As long as I do the same to each side. That's still a 30, 60, 90, because look, if I do sine of 30, 4 over 8, still get a half, still 30, 60, 90. And just like I can multiply every side by a number, I can divide every side by a number. I need this side not to be 2, I need this side to be what? 1, because it's the hypotenuse. I'm going to divide every side by 3. Now look what happens. First of all, do I still have a 30, 60, 90? Yeah. Yes, as long as I do the same to each side. This turns into square root of 3 over 2, which is your 0.866. This turns into your half. And now I know what this point is on the wagon wheel. Square root of 3 over 2, 1/2. I don't need the wagon wheel to tell it. I can figure it out myself. But there's also some simplicity in this. Although it looks worse, right? Doesn't my triangle look bad? I mean, for me, it looks worse because of all the fractions. I think it looks nicer there. I'm going to change that 2 over 2 to 1 at least. But now there's some simplicity in my triangle. And the simplicity is this, or in this picture here, in this diagram. If I said find the cosine of 30 degrees, what's the saying? What are you supposed to do? What are the words? Cosine. What over what? Okay. Adjacent over hypotenuse. My hypotenuse is 1. So what happens when I divide by 1? Stays the same. So it's just this. Square root of 3 over 2. So the x coordinate is actually my cosine. If I want sine of 30 degrees, what's the same? Opposite over hypotenuse, but my hypotenuse is 1. So it's sine of 30 is just, so notice that the point, that's actually here, that's actually cosine, and that's actually sine. And that's why the unit circle is so nice, because the coordinates are the cosine and sine of the angle. That's why we like it. Because when you see the point, you automatically know the sine and cosine. So they'll give you this whole thing diagrammed out. Like we'll show you something else. Now, so let's just say they do this. Let's do this one here. We'll go to here. They draw this and they give me the point. Let's just make sure I do it right. It should be negative 1/2 square root of 3 over 2. That's this angle. Okay. Now, how could you, without doing sine and like without drawing a triangle, how's a way I could test to know that that point is really a legit point on the unit circle? What could I do? Like, how could I really say that this is on it, rather than me just telling you it's a point? Plug it in. Plug your x in, plug your y in, should equal to 1. So let's see real quick. Is negative 1/2 squared plus square root of 3 over 2 quantity squared, does that equal to 1? Well, let's see. What happens when you square a negative 1/2? You get what? 1/4, positive. What's square root of 3 squared? 3. What's 2 squared? 4. So square root of 3 over 2 squared is 3/4. So what's 1/4 from 3/4? 1. Boom. It's a point on the unit circle. Okay. Now, whatever this angle is, I'm not going to tell you what it is. It doesn't matter. But what do I know? This angle, this one should be the what of this angle? This answer. That should be the sine of the angle. This answer should be what? The cosine. That's exactly right. Does anybody know what that angle is? 120. That's right. Very good. That's 120. You might see it in radians. Okay? I might put it in radians. Now, so it's going to ask me, what for this angle, what's the cosine? Well, I'm there. That's it. What's the secant? Take your cosine and flip it. So what's secant? -2. Very good. What's cosecant? Take your sine and flip it. 2 over square root of 3. What's tangent? So what if they ask me, here, this is jumbled here. But notice, see, if I want, because look, if I make my triangle, that's negative 1/2. That's square root of 3 over 2. That side has to be what? 1. But you're dividing by 1 when you do your hypotenuse, right? I don't need to make the triangle. I'm just trying to show you a shortcut. So the cosine of the angle on the unit circle is always the x. The sine of the angle on the unit circle is always the y coordinate. What if we want tangent? How do I do tangent? Sine over cosine. That's how you do it. Sine over cosine. Yes, opposite and adjacent, but sine over cosine, or your y over your x. All the same. So now you're going to have to deal with fractions a little bit. Square root of 3 over 2 over negative 1/2. But a little trick. Anytime you divide and the denominators are the same, guess what's going to happen to those two? They will cancel, because when you flip and multiply, those twos cancel, and you're left with the two numerators. Square root of 3 over negative 1, or negative square root of 3. There's your tangent. So you can find tangent by doing sine over cosine. Or, I mean, if we're trying to get, what my point is, I don't want you to have to draw the triangle. I just want you to go straight to the coordinate. Okay. So, whatever this point is here, the point xy, and this is my angle. What do I know? What's cosine of theta? X. What's sine of theta? What's tangent theta? Y over x. Okay? All right. Everybody in agreement? The dots are connected then for us, okay? Now, here's where it gets pretty cool. Remember the other day I showed you that sine and cosine are waves, right? I'm gonna erase these identities, you got them? And it's gonna review your reciprocal, you'll probably get a review of your reciprocal identities, you'll get a review of your Pythagorean, those will be in there, okay? So, remember the other day I drew the sine graph, so it looks something like this. And I was telling you that, look, the highest you can get is 1, and the lowest it goes is -1. You can get positive answers and you can get negative answers. I was trying to explain how you can get those, because it's actually a wave. All right. What angle is this right here? I need one answer, right? We could say -2, so we don't want to get all fancy. 450 degrees? Yeah, it is 450, but let's just use 90. What does the cosine of 90 degrees have to equal according to our discussion? 0. Cosine of the angle on the unit circle is always the x on the unit circle. 0. What's sine of 90? Type it in and see. Make sure you're in degree mode. Is cosine of 90 0? Is sine of 90 1? See or no? See. Now you can do that for all of the we call those quadrant angles. So angles that are on an axis, we call quadrant angles. All right, well, what if I want tangent of 90? How do I do that? Y over x, 1 over 0, so can you divide by 0? You put undefined. It's okay. What about cotangent of 90? How do I do that? 0 over 1, very good. What do you get? 0, excellent. How do I do secant of 90? Yeah, or remember, secant's 1 over cosine. It's 1 over the cosine of 90. Because, how do you flip 0? It's like 0 over 1, right? So the cosine of 90 is 0, so 1 over 0, what do we say? Undefined, running out of room. All right, how do I do cosecant of 90? That one's easy. If your answer for sine is 1, what's the reciprocal of 1? 1. Okay. Sine of 3 pi over 2. Sine of 3 pi over 2. So number 1, I got to know where 3 pi over 2 is. And I got to know which coordinate am I looking at, x or y. So is that point on the board? Yes, it is. Yes, it is. So where's 3 pi over 2? 0, -1. It's this angle here. 3 pi over 2 is the same as 270 degrees. Bam. So what's my answer? -1. So notice, what is the largest answer I can ever get for sine? It's at 90 degrees, and it's 1. That's the biggest answer I'm ever going to get. Because most of the time, what happens with sine? If you do opposite over hypotenuse, hypotenuse is longer than opposite, you get what type of answer? Less than 1. So the largest answer you're ever going to get for sine is 1. What's the smallest answer, or the biggest negative you're ever going to get? There you go. That's the range of sine. There you go. You see it right here. It's bounded by 1 to -1. The way. Now, what happens? Why does it do this? Think about it. So look, this is 90. This is pi over 2 right here. That's 90 degrees. We just don't put degrees on a linear measurement. See, that's pi over 2 is the same as 90. So there's that. Here's your 270 right here. See, that's 3 pi over 2. Guess what this is right here, where it's 0? Where is it 0? Yeah, that's right, that's pi. That's it. So really all that's happening is, imagine the circle. It's just unraveling. And it goes forever, because you can just keep unraveling it. See, here's your 0, 0, right? There's that one. That's where sine is 0, right? Remember that point there. This rolls, that's up there. All right, this point here, that rolls, see, it's just unraveling here. This point down here, that's here. Okay, and then we're back again, and we just do the whole thing again. So it repeats because you just go around the circle again. This is 2 pi, back to here, 0. Okay? All right. But the biggest takeaway that we need to get is, this happens, it just gets, stuff everywhere, so now we gotta calm it down and redraw it real quick. All right. Ready? How are you gonna know it's the unit circle? It's gonna tell you. You're gonna say, this is the unit circle. And then it's gonna say, here we go, let me think of a good, yeah. All right. Negative 12 13ths, 5 13ths. Is that a point on the unit circle? Well, you're going to take their word for it, right? Because you don't want to have it every time. Negative 12 13ths squared plus 5 13ths squared. Does that equal to 1? Well, it does. Trust me. Okay. Think. What's that Pythagorean triple? 5, 12, 13. You divide each side by 13. Now your radius is 1. All right. So here's what I want you to do. Here's your angle. Find sine theta, cosine theta, and tangent theta just by using the point. I hope that you got it. You don't need a triangle, just use the point. Should take you 2 seconds. And then do the countdown. All right. Since it's a point on the unit circle, the sine of the angle that hits the point is always the what? The y. What's sine theta? What's cosine theta? That's the beauty of having the unit circle. What's tangent theta? Yeah, negative. I like that you did that. I don't want you to say 5 over negative 12. So it is y over x. And remember what I said, your denominators will cancel. And there you go. And I just I like that you brought the negative to the front. Bam. And if I want cosecant, secant, cotangent, I just do what? So just to finish with, cosine of theta equals the x value on the unit circle, if we're dealing with unit circle. Sine of theta equals the y value on the unit circle. Okay. Last question here. Let's say that I tell you that the x is 3 square root of 10 over 10. And I hate that they do this. I know they're going to do it. They're going to rationalize. I would probably de-rationalize this if I was going to work with it. What I mean is, this ratio they've already rationalized. So what if, last question. I'm telling you that x is 3 square root of 10 over 10, and this is on the unit circle. Can you figure out what y would have to be? And how would you do that? So we're all on the same page. Think for a second. This is, where am I telling you this? It's on the unit circle. It's here. It could be first, what other quadrant could it be in? No, X is positive. First or where? Fourth. X is positive. It could be a point here or it could be a point here. So there's two solutions for Y. How are we going to find Y? There. Plug and crank. You know your X, sub your X in, solve for Y. That's how you do it. Go ahead. Use your equation of your unit circle. You should get two answers for Y. And then if they're more specific, hey, it's a point in quadrant 1, then you give the positive. But you will need to be exact because, right, you want to give it'll say give your answer in exact form. So. I'm going to show you what I would do and how I would work it. So I might work it a little simpler, and I should get the same answer as you. You should get either square root of 10 over 10 or 1 over square root of 10. You should get it to the bottom. You should get 1 over square root of 10 or square root of 10 over 10. You rationalize. Okay, so the first thing, I'm thinking one step back. Rationalizing doesn't change the value, just changes the look. So I know that what they did is they took 3 over square root of 10 and rationalized it. So I would much rather work with this. That's just me. You know, I'll work it both ways, but that's how I would work it. All right, then I'll plug this in. 3 over square root of 10 squared plus y squared is 1. And when I square, what happens when you square a square root? Yeah. So you're going to square the top and the bottom, and this should turn into 9/10. All right. If you did that, well, you would have had 90 over 100. Still, guess what? 9/10. See, so just reduce it. Everybody with me why it's 90 over 100? Because if you square this, that turns into 9. See, you got to square everything. 9 times 10 over 100. Okay. All right, so I get 9/10 plus y squared is 1. Okay. I got to solve for y. So where does the 9/10 go? To the other side, right? Well, subtract 9/10. Well, what's 1 minus 9/10? 1/10. But that's y squared. Y squared is 1/10. Square root, square root. So I'll show you how you get an answer from square root of 1/10. So you know y is plus or minus the square root of 1/10. Well, the rule for square roots is this. If you have the square root of a fraction, you can take the square root of the top and the square root of the bottom. And there's where you get your 1 over square root of 10. Plus or minus 1 over square root of 10. And then if I rationalize square root of 10, that's how you do it. So if they give you one of the coordinates, you can find the other coordinate by using this. Because that's the equation of your unit circle. If I know my x, I can find my y. I know my y, I can find my x. Last thing before I mic drop, okay? This one is, I love this. Nice. You feel better about the unit circle now? I do too, because I always get intimidated by that thing. I think this just simplifies the thought of it. Last thing. What did you say, what did we say on the unit circle? What does x equal? Cosine of whatever the angle is, right? So x is cosine of the angle. What's y? I'm going to plug those in. what I got. Don't leave me hanging. Last thing we're finishing with, Pythagorean identity. Remember, you write it like this: cosine squared theta, cosine squared theta equals 1. You can change the order, sine squared plus cosine squared. Boom. Where it comes from. Okay. That's it. Nothing more will I teach you today. Hopefully this is a good part 1 to unit circle. Let's get into the homework. You guys at home, get into the homework, delve into it. I will take their questions. Of course, I won't see these guys again until Tuesday. We'll plan for another Zoom on Tuesday for the ones at home, okay?